Domain of quadratic function y is equal to x squared plus 2x minus 3 is equal to x is greater or equal to -3 but less or equal to 2. Solve for a range of a function. First of all, there are two cases in our quadratic function, and they're both defined by our leading coefficient, which we usually notated as the a value. So the both cases were going to be defined by our leading coefficient a. So the first case in our quadratic function will going to be the case where our a value, our leading coefficient, is greater than 0. Which means when our leading coefficient is positive value, the graph of our quadratic function will open or go upward. When the quadratic function goes upward, such as this format that keeps going to our upward never intersects at some point, but then it will contain one point, which is another most important thing in our quadratic function, which we call it as the minimum or the lowest point on our quadratic function. And this will going to be defined with our a value, our leading coefficient, is positive value. So our second case in our quadratic function will going to be the case where our a value is negative value. When it is negative value, the graph of our quadratic function will open or will go downward, unlike the first one. So the downward will going to be the opposite of the upward, and it should always be the opposite as a graph from the first one, which will look something like this, that keeps going toward downward and never intersects at some specific point. But then it will contain one point, which is another most important thing other than the minimum point, which we call it as the maximum or the highest point on our quadratic function, and this will going to occur when our a value is less than 0. And from here we can think about our definition of our vertex. So the vertex in our quadratic function, the actual meaning can be the addition of the number of possibilities between the minimum point and the maximum point, and its addition of the number of possibility we're gonna take or make the vertex in our quadratic function. When it comes to solving for the quadratic function problem, we need to think about the graph of a quadratic function. And for the graph of a function, all you need to think about in order to graph perfectly is to think about the vertex of our quadratic function. And we thought about the properties, how to solve for it, not how to solve for it, but the property that the vertex contains. If you go back to our question, it says it contains a range and the domain of a quadratic function. And when you think about its definition, what does it mean? So the first case we're going to be what is the domain of our quadratic function. So as we did in the last video, the domain of a quadratic function will going to be the range or the limitation of x values, range of x values, which means same thing with the limitation of our x values in our quadratic function's graph. So for the second one will going to be the range of a quadratic function. And for a range of a quadratic function, it is exactly the same concept with our domain, except it is the range or a limitation of y values. These are the difference between the domain and the range of our quadratic functions. So from here, we can know one thing, that our domain, they gave us the domain of our quadratic function, which means they gave us the limitation of our x values, which will going to be x. So the x value can be either greater or equal to -3, and also less or equal to 2. This will going to be our domain of our quadratic function. And from this domain, we need to solve for our range of our quadratic function. And from that, we need to solve for our exact value or the exact format of our graph of our quadratic function. So in order to solve for a graph of a quadratic function, we need to think about how to solve for a vertex in our quadratic function. So if you write our domain again, -3 x and then +2, this will going to be a limitation of x values in our quadratic functions graph. So first of all, let's review what we did, how to solve for our vertex in our quadratic function. The first way to solve our vertex in the last video was to solve it by the vertex form. And if you review what the vertex form will look like, it is a form that we convert through our standard form. And our standard form was y is equal to a times x minus p squared plus q. And from here we can see that y should always be the output of our quadratic function. P and then q value should always be, so q value will going to be the y coordinate of our vertex. And for our just p value, not a negative p, we're going to be a x coordinate of our quadratic function's vertex. Standard form, if you convert it into a perfect square form, we're getting a vertex form. So we reviewed the vertex form, so let's think about what the standard form will look like. The standard form's basic structure will going to be y is equal to ax squared plus bx plus c. And in this case, our function that is given, y is equal to x squared plus 2x minus 3, will going to be our standard form. So if you also write them down, y is equal to x squared plus 2x minus 3. If you think about what this each variable does, as we can see, y should always be the output of specific function. And for that a value should always be the leading coefficient. So a value should always be the leading coefficient. And if you see the difference between just a coefficient and the leading coefficient, we're going to be defined by the term leading. And if you think about what the leading will look like, our leading means it is the highest degree power term. And the highest power term in the quadratic function will going to be x squared. So our a value will going to be the coefficient of our highest power term, which we called it as the leading. So that makes the whole difference between just a coefficient and the leading coefficient. And the c value will going to be the y-intercept. If we convert y-intercept into a specific coordinate, it will going to be y is x is equal to 0, and our y value exists. Which means when our input of our function, which we usually notated as the x value, is equal to 0, our output of our function, which we usually notated as the y value, will exist. And the reason why we just wrote as y not a specific value is because y value is equal to variable. And also so the x value. And if you think about what this variable means, that means it changes all the times, depends on time. So our x value, input of our function is input, is variable. Output of our function, which we usually notated as y value, is also a variable. So from here, we're going to want to think that from the standard form, which we show it, y is equal to ax squared plus bx plus c, our standard form, into a perfect square form, which we can get through completing the square. We're gonna get the output as the vertex form. And this was the first way how to convert the standard form into a vertex form in order to solve for our vertex in our quadratic function, which we usually notate it as the x comma y, but in this case p comma q from our vertex. But in this case, the point we're going to be different, which means instead of solving for a vertex of our quadratic function by 3D vertex form, we're going to solve it through our formula for it. And our formula was to solve for our x coordinate in our vertex, and in our vertex it is usually p comma q, where a p value in this coordinate will going to be the x coordinate, and our q value will going to be our y coordinate in our vertex. And this formula for solving this is to solve for our x coordinate of our quadratic function, which will going to be negative b over 2a comma y. And we could see that our negative b over 2a will going to be the input of our function, our x value. Our y value will going to be the output of our function. And there is a way to solve our y value through our vertex or in formula, but the reason why we're just solving for our input is because not to get confused, and also if you just know the value of our input, all you have to do is we need to input that value back to our original function to get our output of our function. So that's why we are only solving for the inputs formula. So from here we can actually input it to solve for our vertex of our quadratic function. So from here, so negative and the b over 2 times a. And if you think about what the b will going to be, the b is a coefficient. And it is not a leading coefficient, it's just a coefficient of the first degree power term, which means it is a coefficient of x first power. This will going to be what the b will look like. And the second case, we're going to be what is a. And as we can see, a will going to be a leading coefficient, as we can see it through our vertex and the standard form. And the leading coefficient and the coefficient is different because of the term leading. So when you think about these two things, so we can actually input some specific values in order to solve for b and an a value. So first of all, let's think about what our b will look like. The b will going to be our coefficient of our x term, which will going to be 2. But we have negative 2 over in the denominator. Instead of a, we can input our leading coefficient, which will going to be just 1. So 2 times 1. And we were gonna get negative 2 over 2, which can be simplified as the negative 1. So negative 1 is not just a full coordinate, we're going to be just an input of our specific function, which means when you convert this into a coordinate, it will going to be negative 1 comma y value. And from here, in order to solve the actual coordinate of the of our vertex, we need to solve for our output of our function, which will going to be y. So we can actually input our negative 1 back to our original function, x squared plus 2x minus 3. So we can, if you write it down, it will going to be y is equal to x squared plus 2x minus 3. So as we can see, we can input our formula back to our function. So our b value will, so our x input will going to be 1, negative 1. So if we input our x value as the negative 1, it will turn into y is equal to 1 minus 2 minus 3, which will going to give us negative 4. So our negative 4 will going to be our output of our function, and that will going to be our y value. So if you think about our full vertex will going to be -1, comma, -4. This will going to be our full vertex. So we can actually think about what we're going to look like. First of all, let's think about what type of graph will it look like. So the graph will go upward, as we can see that our leading coefficient is positive value, +1. So the vertex of our quadratic function, which will going to be -1, comma, -4, it will going to be a minimum point of our vertex. So if you draw not exact, but a rough drawing, it will look something like this that keeps going to our upward. But then we're going to contain one point, which will going to be its minimum, or the lowest point on this graph. And the coordinate will going to be -1, comma, -4. This will going to be its vertex. So, as we can see, the domain of our quadratic function is exactly the same thing with the range of the x value, which means we're thinking about, we know that the quadratic function keeps going toward upward and never intersects, but then we're thinking about the limitation of the graph. So first of all, let's write our range down. First of all, so range of our domain was -3, x, and 2. So this will going to be our domain of our quadratic function. So the x value can be either between -3 and 2. All you have to do is we need to input this coordinates, or the x value back to our original function to get our range. And the range will going to be the range of y coordinate in our function, or the y values. So if you input -3 to our original function, and our original function was y is equal to x squared plus 2x minus 3. If you input 3 to our x value, it will going to be y is equal to -3 squared minus 6 minus 3, and this will going to be equal to 0. Now let's think about this second case where it talks about 2. If you input 2 into our quadratic function, it will going to be y is equal to 4 plus 8 minus 3, which will going to be our output 9. So the x value should be between 0 and 9. So if you kind of think about if you did it exactly right, so -3 squared minus 6 minus 3. So we inputted -3 as our value. -3 squared minus 6 minus 3 minus 9 plus 9, it was 0. And secondly, we inputted 2. If you input 2, it will going to be y is equal to 4 plus 8 minus 3, which will going to give us 9. So our answer for this question will going to be the range. So we're talking about the y value. Y can be either greater or equal to the lowest one, 0, or the less or equal to the highest one, 9.